So the second method of thermal transfer I want to talk about is convection. And so this is the transfer of thermal energy between liquids and gases. And what primarily concerns us with our house is through the air, through gases, okay? And we get this phenomena called the convective loop happening, okay? And this is a pretty good picture here. So we've got our heater, it's heating the air, it rises, it's moving because air is less dense, warm air is less dense. And then it's moving towards this cold surface, which are these windows, okay? Most specifically the glazing on the windows is cold, so the air near this window is going to be cold. These are going to move towards each other, they're going to mix, and then it's going to move back towards that warmer air over there. So, suffice it to say, the temperature of the room is insignificant if you have lots of cold surfaces or lots of air movement in the house, okay? It can be 73 degrees inside your living room, but if you're standing next to a really cold window and you're standing in cold air and you're feeling cold air moving on you, you're going to feel cold. You're going to feel uncomfortable, okay? The other thing that can happen here is if you're actually losing air, and where that usually happens is you're losing it up into the attic because lights aren't sealed, plumbing fixtures aren't sealed. Air is going to escape into those unconditioned areas, and air is going to be replaced somehow, okay? It's going to maintain a constant pressure. So if you let air escape into the attic, it's going to pull it in from anywhere else it can, okay? And this is called the stack effect. And so I do need to go back to this quote here because it's something that you're going to hear for the rest of your lives probably. But this idea that houses need to breathe, okay? Houses need to breathe, and what they're trying to say when they say that is it's okay to have holes everywhere, okay? There's a belief that having a leaky house that's not airtight is good, okay? We've kind of established that it is to a certain extent, okay? If you have an old house that's uninsulated and made out of old growth redwood, let it leak all over the place. Sure, great. It'll help it dry out, okay? But there's no half measures here, okay? You can't just kind of insulate the house, but leave a bunch of holes all over the place and expect it to be effective, okay? You either do it or you don't do it, okay? So if you're gonna insulate it, you have to make it airtight and air seal it, okay? Not only do you run the risk of leaving condensation behind in the walls, but you're gonna create the stack effect where air is escaping into the attic and air is going to be pulled in from the outside to replace that air, okay? To get technical, we're losing conditioned air and we're bringing in unconditioned air, okay? Now, we don't want to be introducing the air from underneath the house, okay? Maybe there's a dead raccoon under there or something, okay? And then the biggest thing is the air outside is really cold, and we're going to have to be constantly reheating new air if we're stuck in this stack effect cycle where we're losing air, we're bringing in air. Okay, that's going to be problematic and costly and uncomfortable, okay? All right. Radiation is the third thing that we're going to talk about, and this is mostly from the sun that we're talking about, radiation, but it's the transfer of heat or thermal energy through visible and non-visible light, okay, through ultraviolet light, all right? So this is a pretty good picture of lots of different ways that heat moves through windows, okay? So we've got convection up here at the top. Maybe this window's poorly sealed and we've got air leakage up here, okay? we're going to have conduction through the frame itself, and then we're going to have conduction to the glass, and then it's going to conduct through the glazing spacer bars, okay? So the way this insulated glass is conducted is there's two pieces of glass, and there's spacing bars all the way around it, and then remember, it's filled with some sort of gas, but it will conduct around those spacing bars. And then the biggest way that we're going to lose heat through a window, or gain heat, depending on your climate, is through radiation, okay? And heat will radiate to the glass, conduct through the glass, and then radiate to the outside or to the inside, okay? And so this is kind of a two-way street. If it's hot outside and we're trying to keep it cool inside, the sun's going to radiate towards that glass and eventually make these pieces of glazing hot spots. They're going to be radiating heat into the house, okay? Same thing, if it's really cold outside, it's going to radiate cold towards this glass and then conduct cold through the glass into the house that we're trying to keep warm. Or we're trying to keep the inside of the house warm, we're going to radiate heat towards the glass and it's going to move that way, okay? This constant flow of areas of more heat to areas of less heat, okay? And we can't really stop it. Windows are a big weak point in our thermal envelope, okay? So we already talked about how the sun heats with radiation, and so this is a pretty good example of passive solar, okay? This concept that hopefully you guys are familiar with, but you can design a house in such a way, and this makes more sense in like warm areas, but you can design a house in such a way that it's positioned to take advantage of the sun, and it's constructed to take advantage of the sun, okay? So when the sun is high, or like more centered in the sky, during the summer, it's radiating down, and the overhangs on the house are preventing a lot of that radiation from entering, okay? But then when the sun is low in the winter, it's more horizontal than vertical. It's able to shine through the windows, okay? And heat, we're taking advantage of free heat from the sun coming through the windows. And then this is pointing to thermal mass. So this house has a slab. The sun is heating up the slab with radiation, okay? Not like bad, like nuclear radiation, right? Just ultraviolet radiation, heat. And then this thermal mass heats up over the course of the day and then slowly releases heat overnight, okay? And so, our bodies are radiating heat also. If we had a block of ice in the middle of the floor, that would be radiating heat, but it would be not much heat. It would be radiating cold, okay? What we can do, and again, windows being the biggest weak points, if we install low E glass on these windows, that will do a lot to reflect the radiation, okay? And that low E stands for low emissivity, okay? We could do low E glass on both sides also, if we wanted to reflect radiation back into the house, and if we wanted to have low E glass on the outside, we could reflect radiation away. I don't think low E glass is really great for our area, at least on the outside, because we want that radiation from the sun, okay? We want to get all the solar heat gain we can, okay? If you're concerned about losing heat inside your house, curtains actually do a lot, okay? Curtains will reflect a little bit of radiation from inside the house or from the outside. If it's cold, you got the curtains closed. Those will actually go a long way in kind of keeping a little more constant temperature inside the house. There are also insulation products that have a foil face on them, and that is meant to counteract radiation, okay? be very careful with these because that foil face is also going to be a vapor barrier, okay, if you install it correctly. So that can be problematic if you're using an insulation like this in the walls, okay? Where I think this would be effective is if you put this in the attic, okay? You have this foil face facing up if you're worried about picking up heat from the attic, okay? So let's say we're in a hot climate and I'm installing this fiberglass batt insulation with a foil face. If I have this foil face pointing up towards the rafters, there's going to be a lot of heat radiating from the sun onto the roof, conducting through the roof framing, and then radiating back towards the ceiling, and then conducting through the ceiling, and then radiating into our house that we're trying to keep cool. So if you have this foil face pointing up towards those rafters, that's going to reflect that radiation, prevent that radiative heat from penetrating through that material, okay? But again, insulation is dangerous in the wrong hands, okay? Put this stuff in the wrong place, and all of a sudden you've got a vapor barrier where you might not want one, okay?